So got a couple of interesting things coming up in this video for you guys. We're going to talk about atmospheric CO2 in parts per million. As you can see very briefly, it's at 408 parts per million when you put the CO2 detector outside. Before we get into it, big thanks to those people that support us on Patreon and on PayPal. And you know, guys, without you, nobody would have these answers. So first of all, you know, you should pat yourselves on the back for supporting this observatory, even at this time where the observatory receives, you know, as little donations due to the festive holidays, and you know, it is to some reasonable you know, expect that is the case. Okay, let's get into it. So yeah, we know through having now our own CO2 detector what the parts per million is in the atmosphere, and the government organisations have rightly come out and told people that it is, you know, around about the 400 mark. In fact, you know, I've heard mention from these organisations that it's 406, but as you can see, we're getting a slightly higher reading, 408 parts per million. But there's not a lot in it in any case, because you know, this is a trace gas that we're looking at, and this is one of the least things in our atmosphere, but it is causing you know, hysteria in the media, and of course, you know, people around the world are being taxed as a result of this, and it's nothing but a fabrication and an excuse to make those taxes. I did do a 30-minute drive from Coventry to Birmingham here in the United Kingdom today in England, and I'll show the results of that. I'll just quickly tell you though that they are about 750 parts per million, but I've got to say, we did have the blower on in the car because it was 4 degrees when we got in the car, so it was quite cold. But then, you know, when you have the blower on in your car, you're also circulating fresh air, so that the parts per million are going to be around lower levels as opposed to when you don't have the blower on in the car. But I wouldn't expect these to start getting, in any case, into the toxic range of over 2,000 and going on to 5,000 parts per million, because that's when you really should be concerned about the levels of CO2 and not before. You know, in my living room, just having the CO2 detector now for a couple of days, you know, it's not uncommon to see 1,000 parts per million in the living room. And you know, you've got to ask the question, if it's so bad outside, you know, at 400 parts per million, then it must be really bad in my living room right now at 1,000 parts, and uncomfortable as a result of that. But again, you know, it is well within the green you know, environmental conditions for, you know, anyone living in those ranges. We've got some interesting data I want to show you from from the Gold Coast, Australia, because it seems to be following the trend that the Hong Kong data does, in that it's losing recently around 4 microteslas. That's about 7% of the magnetosphere strength of our planet, to put it in context. So, you know, we've now seen 2 of our global magnetometers show a drop in you know, the magnetosphere strength in those regions, or the magnetic intensity in those regions. So something could be gearing up to happen, guys. I'm just putting that out there. You know, we've seen this anomaly occur on 1. We thought that might be to do with the South Atlantic anomaly now creeping up in the gap between the 2 continents there, and you know, now we're seeing 1 in Australia do the same thing. So we'll have a little look at that data. But before we do, we'll just have a quick look at the data from the 30-minute commute from Coventry to Birmingham. As you can see, the atmospheric CO2 parts per million did increase to 745 from 408, and you know, that's just a result of 2 people breathing in a car for 30 minutes with the blower on as well. So if the blower had been switched off, that probably would have gone up to around about 900 parts per million, but wouldn't have been an uncomfortable journey as a result of the parts per million of CO2 in the car environment at that point in time. I also had in the car this morning with me the oxygen sensor, and as you would expect, we're not going to shift a lot of oxygen even if the CO2 does increase slightly. And you know, you can see on the bottom line there, 21.36% oxygen. What you've got to remember is these little trace gases such as CO2 are not going to affect the oxygen in the atmosphere because of the sheer amount of oxygen that is in our atmosphere. But again, you know, without building this equipment, we could only guess and speculate of what would be the scenario. We've actually got the equipment and we can put it in the field and test it now and get the results. So we know a couple of things from just a few days of now having the oxygen sensor and the CO2 sensor. The oxygen is very rarely affected unless you're breathing directly on the machine CO2 into the oxygen sensor. Then it saturates the sensor and gives a lower reading. I've showed you that. I'll show you a little bit later on in this video doing the same thing with the CO2 meter, and the alarm will go off on it as soon as it peaks over 2,000 parts per million. But the point is this: without people funding the observatory, we wouldn't have been able to first of all build the equipment or buy the equipment, and without that we can only guess. But with the equipment and with a bit of funding, we don't have to guess no more. We can make the measurements and we can state that this is the case. So we know that there's 408 parts per million in the atmosphere, and we can monitor this now. So if they start saying the CO2 is going to go up and up and up, well, if it doesn't go up on our equipment, then obviously they're lying. But here's what I'm going to forecast, guys. We're going to start to see CO2 drop in our atmosphere as a result of the temperature already dropping on this planet. And what you've got to just give it a little bit of time to happen is the inertia to catch up. So remember, when the temperatures drop, our oceans absorb more CO2 as a result of that, because oceans can hold more CO2 when the temperatures are cooler, and we're going to start to see it drop slowly over the next months and years to come. So let's have a look at this Australia data. So guys, if you want to go over to poleshiftnews.com at any time of your convenience, you can see the data as it comes in, usually within a couple of days. I've processed it and added it to the website. There's a lot of other things on this website that gets updated, like sunspot activity, solar radiation, we've got KP index, proton flux, you name it. It's just earthquakes, volcanic eruptions, satellite live photos, radar, you name it. We've got ocean temperatures around the world. There's just tons of stuff on there, and it's all updated regularly. So if you want to have a little peek at that, you can. But let's focus on what we're here to have a look at, and that is the Australian data that came in over the last few days. And as you can see, big thanks to Richard over there on the west coast or Gold Coast of Australia, has sent us his data. And he mentioned that he'd noticed a drop, and rightly so. He is correctly observing a drop. If we just look where we first started collecting reasonable quality data, you can see that it starts at 81 microteslas, and over the period of time we can see that 81 starts to decay from there. Then it goes down, touches a couple of times 80, and then we see creeping below 80, 79, and towards the end of this chart, the most recent one, it is at 78 and still appears to be decaying. So showing the same things as what Hong Kong has over the last 5 months. So maybe there is a pattern. I've asked Jeff on the in Perth, Australia, on the east coast, to drop us some data in so we can have a look to see if anything's been changing that. But what you've got to remember is with Jeff's data, it's relatively new because he's recently had a new magnetometer over there. But let's just see if there has been, in the time that he's had that magnetometer, some noticeable decay. I also sent JD in Southern California a quick message asking him if he could drop over some data, because we've had none for around 3 months now, and I'd be really interested to see what's going on in Southern California. If we don't get no data by the new year, we'll put another magnetometer out there, or we'll ask JD to pass it on to somebody else who can afford a bit more time and regularly send the data. And I've also messaged Brad, and he's usually good. He's dropping the data into us every month, and we should shortly be having some data off him. So yeah guys, we've got quite a bit going on. As you can see, a bit later on I'm going to be trying to chase up our delivery of our silicon photomultipliers. But here you can see the particular one we want, the Micro FC 635 SMT TR1s, and they do sell them singularly, £44 plus shipping. The last one come out to about 80 something pounds with VAT added on top of that as well. But when you order this at the moment on this website, they're saying that they've got none in stock. But if you go down here, you'll see what the problem I'm having is. They do have another supplier, but will only supply 3,000 of them. But obviously you can see the difference in the price comes down when you order 3,000 of them. But these are the particular silicon photomultipliers that we use, and we've ordered before off Arrow with no problems buying single ones, but for some reason this time they're out of stock, so I've got to chase up that later on, because that is the only thing really holding up now, our equipment that's going out in January. You know, it give me a couple of days to, or 2 or 3 days to build them, the muon detectors. We've got to then include in that package a couple of magnetometers and a couple of Geiger counters. So we'll try and make, you know, get as much data from these 2 packages that are going out to Brazil and South Australia. So that's where we are with that, guys. And just before we end the video, I'll offer anyone that can get me a 2019 space environment overview from whoever produced this one. I'll get you a bottle of wine, you know, if you can help me. I've tried to find this on the internet when I've been doing my searches, and I've not had much luck. But if you've got some more time to invest in searching out a 2019 space environment overview, and that's just so I can have a look at what's going on towards the end of solar cycle 24 more in depth, you know, I'll definitely send you a bottle of wine for doing that for me. As far as I'm concerned, all the information with regards to solar activity is on this space environment overview. I think it needs a bit more time to actually go into it, but what we can see from the left hand side to the right hand side and down all the columns, doesn't matter whether we're looking at the monthly smoothed sunspot numbers or the daily sunspot numbers, the Moscow cosmic rays, GOES X-class flares, you name it, it has all dropped off towards 2015. And you know, you can see it clearly. You don't really need to study the details, you just look at, say, GOES X-class flares from this part of the solar cycle 22. You'll see that when it comes to solar cycle 23, there's no densely packed region in the chart like there, and even less at solar cycle 24, and that's the case for everything. You know, another fact, guys, while we're on the, you know, the matter of facts, because that's really all we're interested in, this is the only space environment overview that I have found that showed something quite different that has happened with the solar output, as well as solar activity dropping off, and that's you know, a major concern in its own right. We can see clearly when we look at the Moscow cosmic rays R246, which is the third part of the charts going down, the data there, we can see that at the solar maximum of solar cycle 24, cosmic rays are still coming through the heliosphere. And if we look back at all other solar cycles 22, 23 and solar cycle 23, 22 and 21, we can see that that's new territory we've crossed into, because it doesn't happen. There is no cosmic rays still coming through over the line of data at the maximum of solar cycle 22 or at the maximum of solar cycle 23. But if we look at solar cycle 24, we can see there is a crossover, which means that more cosmic radiation is inbound despite there being solar maximum, and that means that our heliosphere, which is created by our sun, is no longer strong enough during a solar maximum to stop the amounts of cosmic radiation now creeping in. Another thing we can note, that if we go back to solar cycle 22, after the solar cycle, you know, and it begins solar cycle 23, we can see the peak of cosmic radiation. And if we just compare that at the end of solar cycle 23, we can see it has more than doubled. So we could project that even though we haven't got the space environment overview of 2019, if we was looking at it, that the amounts of cosmic radiation at this point would be even more so than that. And I think that that's why I've struggled to find a space environment overview of 2019 or even 2018. So, you know, there's a little reward there if someone wants to go and have a look on the entire internet to see if you can find a space environment overview. It's got to be the same one as what we're looking at, produced by the same company, and it's got to show all the other data sets in it as this one does, so that we can do some comparisons and you know, make some predictions ourselves. What we are seeing with our magnetometers globally in the field at the moment is, at least with two of them, showing around about 4 microtesla decay over a short pace of time. And if that is the case, then, you know, these organisations themselves might come out and make an announcement to that. They certainly haven't made announcements to some important issues, like, you know, the fact that a high heliosphere is no longer protecting us, even though, you know, we're in a grand solar you know, we're in the solar cycle maximum, and you know, it's still allowing more cosmic radiation in than ever. You know, for me, that tells me that, you know, we are getting deeper down this rabbit hole, and, you know, therefore, you know, the threats to any biodiversity on this planet has increased as a result of that alone. And we can say that for a fact. You know, cosmic radiation usually makes up about 14% of total background radiation, and if that's on the increase, then we know cardiac arrhythmias is going to be on the increase, cancer rates are going to be on the increase as well. So, you know, this is why we stood this, guys. And we've also got to think about more matters related to the pole as well. You know, as time goes on, you know, that window now of 4 to 7 years just shrinks every day from now till then, and it's projected at least from this observatory, mavestar observatory, that when we do get into those weak field lines of magnetism, this pole is going to reverse, and this Earth is going to go through its reversal. And what we could see from now till then is a gradual decay of the magnetosphere. And what we've seen early on from the data that's coming back from Hong Kong and you know, the Gold Coast recently could be early signs of that, you know, really now starting to take effect. So, you know, guys, I'm going to leave it here. No, this is a public funded website, and I bet you already a lot of you have ended the video right now. But, you know, without the funds, no more of these facts are going to come to light for you guys. And that's why it's important to keep a publicly funded observatory funded, even during the worst times of the Earth. So, you know, there's a link there if you want to help do that. And, you know, I'll just wish you a great day on top of everything else. You know, you've got to keep your chin up. And although things aren't fantastic with regards to our environment, you know, it's you know, still a matter of putting our head down and carrying on with it as best we can. Before I end this video, guys, I just want to show you something on North School, just quickly. So first of all, we're looking over Antarctica at the Earth. You can see there's a widespread area of sub-zero temperatures. Some of these temperatures go into the minus 35 plus degrees Celsius, so very, very cold regions of the Earth. If you can just pay attention to roughly where it is over those continents, all this sub-zero temperature, I'll just quickly put the jet streams up for you so you can have a look at why that is the case. You can see this main ring around the tropic regions of our planet is pulling down as a result of there not really being a polar jet stream, but more of a polar subtropical mixed jet stream, that cold temperature. And that's why the majority of the northern hemisphere right now is in those sub-zero temperatures, despite even the fact that we are tilted on our orbit around the sun at its furthest point at this point in time. So in other words, just in, you know, in simple terms, we're in the winter, yes, but the jet streams are pulling those Arctic climates further down over towards the equatorial region as a result of there not being, you know, two nice jet streams, one in the polar jet stream region around about 60 degrees, and then a nice one in the tropic regions around 30 degrees of our Earth. And that is the case for the north and southern hemispheres of our planet. If we just have a look over Antarctica, we can see the jet stream all around this region, and if I just go back over to temperature and show you what the temperatures are inside that ring, you'll see that they're all sub-zero. So if I just go back onto surface and temperature, you'll see what I'm talking about. So as a result of this jet stream being low at the moment over the southern hemisphere, and this is a result of it being close to the sun, so the southern hemisphere is in its summer time period right now. But if we look at the temperature of Australia and then compare where the jet streams are with relationship to that, you'll see that most of the strong jet streams are below Australia, and as a result of that, that's why, you know, they're experiencing such you know, high you know, droughts and high temperatures as a result of that. So you know, and that's the same for the case for the United States of America. You know, the reason why the United States of America is experiencing those sub-zero temperatures and cold climate, it's because simply the jet streams are low, and as a result, when the jet streams go low, they also pull down that cold temperature over the Arctic region with it, and you know, they get those sub-zero Arctic blasts. So that's just, you know, so that you guys can go on to North Skull at any time, just compare where the jet streams are, you give you an idea of what's going on. So if the jet stream's above you know, the continent of Australia, then obviously you're going to get a lot of precipitation. If the jet stream's below Australia, you're going to get less, and as long as that jet stream stays low, you're going to get, you know, periods of drought. Where we get this hot air mixing with the cold air in those regions, you stand a greater chance of flooding. And you know, the reason that we're experiencing these noticeable climatic changes right now is because of a relationship of broken jet streams or abnormal jet streams. And some climatologists will admit this. A lot of people will just simply say nothing, perhaps because they've been told not to say anything. You know, and as a result of that, you know, you get misinformation. So there you go, guys. I'll probably catch up with you tomorrow with some more information. Very shortly we're going to do a location of the magnetic North Pole to date. It's usually around about the 17th. I might pull the SD cards out of the magnetosphere sensor and also the Trimag system and get a reading for you a little bit earlier. So yeah, there's a link down there if you want to support what we do, and I'll say what I usually do. Bye for now.